Hello everyone, I'm Jiu Liu. Today I will present about how my research has progressed and the results I have obtained through learning it. Let's briefly touch upon objectives of my research. In this study, I try to reveal what lies between a song title and its musical features like melody, genre, and key, and etc. So my goal is to expand our knowledge of the relationship between them by applying the knowledge acquired through training the model. Additionally, I used a Simile token for the study, and I also prepared some downstream tasks which can utilize the representation vectors obtained through the running process. So I would like to share the results of that later in the slides. Let's talk about the structure of the model. I used two different embedding models to train them with contrastive learning. So the structure of title embedding model is very simple. It uses some pre-trained sentence embedding model inside of it to vectorize a text of title, and I added some linear layer to make the output of the sentence embedding model to the expected embedding size for the contrastive learning. And I also prepared a musical feature embedding model which expecting a input of different types of musical feature like melody, genre, key, and other informations. And I'd like to share how the feature extraction model inside of it is looking like. Fortunately, I had the opportunity to utilize Virtuoso Tune, a music token generation model developed by Professor Zhang. This model operates in an autoregressive manner and is specifically designed for creating Irish folk songs. And since it won first prize in the 2022 AI Music Generation Challenge, I borrowed some certain parameters from it to extract relevant musical features. And as you can see here, this model has a distinctive feature where it concatenates various elements like melody information and measure information and header information, and all these informations are concatenated for training a note level RNN layer. And what is quite special for this model is that it utilizes an attention mechanism to summarize the hidden information generated by the note level GRU at the measure level. So these summarized measures are concatenated with the hidden information from note level GRU for further training in the final level GRU. I conducted experiments by inputting various types of inputs into this musical feature extraction model in order to explore which elements have a stronger correlation with the title. Let's briefly touch upon the metrics that I used in this study. I used mean reciprocal length and discounted cumulative gain to evaluate my model, and both MLR and TCG are metrics based on ranking. For example, for a given title embedding, we utilize the cosine similarity between the musical feature embeddings of all possible songs to calculate the rank to a given query. The metrics are then calculated based on the rank of the song corresponding to the query pair. And here I will explain the experiment that I conducted. The contents that were conducted through comparative experiments were validated using metrics, and a deeper analysis was performed by examining the model's predicted values, actual values of the prediction. And what is interesting is that when plotting the outputs of the musical feature embedding model, it was observed that the output from a model trained only on melody features exhibited clustering by genre. This led to the inference, maybe, that the title has some correlation with header information such as genre and key. And by drawing a histogram of the length information from a pair data of a given query, it was confirmed that the model I trained has a certain level of understanding of the relationship between title and musical features. It's better than the random model. However, unfortunately, I felt that it would be best to temporarily pause my research at this point. This is because that I realized that I do not currently possess the capacity to actively pursue this research. So let's step on. I will explain how I generated some melody from a given title. I just added some title embedding to the token, but initially my plan was to exclude the header information from the tokens to encourage the model to focus more on the title embedding. However, during the inference stage after training, it became evident that the model was largely ignoring the title embedding, and instead it focused on the melody information primarily. Therefore, I decided to incorporate a task of matching the header information with the given title. This matching task involved vectorizing all 180 header information presented in the dataset and through the musical feature embedding model. And so with this approach, I can get the closest header information to the given query. Let's see how the generation process proceeds through a demo. Sorry, I didn't have time to prepare for the web demo, so I think I need to check my script directly for making a generation. So if you write down some title, then you can get some header information from it, from the method that I made, and the header directly goes into inference tab of the model. So let's check it out, how it works. So after the preparation time, you can see the given key from the title is C minor and the rhythm is bar dance. It is a genre of the song. So we can hear some generated song from it. And okay, well, it's quite good. Let's hear how other title can be generated can generate some song. Okay, and we need to change the folder. So after the preparation of time, the song was made here, not all. Let's hear some. So this is the end of my presentation. Thank you for watching this video. And I would like to express my gratitude to those who supported my research and provided some valuable advice. Thank you.